So lightning emits radio waves. That's because there's an ionized channel where the current flows that acts as an antenna. And so for Earth, the peak's at about 10 kilohertz because the lightning channel is typically 3 to 4 kilometers long. So the emission frequency, peak frequency, roughly depends on the size of the discharge. And that means you get planet-to-planet variations in the radio spectrum from lightning. If you have smaller scale discharges with shorter channels, and they emit a higher frequency than the longer channels. And the propagation distance also depends on the frequency. So all these have to be taken into account when measuring lightning at another planet. And this graph here shows that if you were in a spacecraft, let's say just outside, just in orbit of Earth, and you wanted to look at radio signals from different types of thing, it is possible to detect Saturn lightning, which has this quite small signal. It's still lower than a lot of other things, but it is possible to detect Saturn lightning from the radio signals from Earth. And you may be familiar with the Jansky, but it's a very small unit, so these small signals. And Uranus lightning is predicted to be reasonably detectable from Earth as well. So I'll come back to that later. I said that was if you were outside Earth's ionosphere. Of course, the ionosphere, the upper layer, affects the remote sensing possibilities. And if you were in Earth's atmosphere, you wouldn't be able to see any of this. You'd only be able to see a little bit of the detection. But having said that, Saturn lightning has been detected from Earth with radio telescopes, so it is possible. But clearly, it makes sense to be outside Earth's ionosphere. A slightly less well-known form of emission from lightning is a very low frequency signal, which is just a few hertz, which is within an atmosphere. And the lightning excites a resonance between the surface and the ionosphere, and it's called the Schumann resonance. So it depends on the size of the planet. It's 10 hertz or something like that. So this might be a novel approach to lightning detection. I'm not sure whether that signal would be able to get out of a planet's ionosphere at all. It might be interesting to hear your views on that. But certainly if you're within the planetary atmosphere, you could look for these Schumann resonances, and that would also indicate there was lightning there, as well as these other radio signals. So you will probably know that all radio waves are also magnetic signals, and this means that lightning radio signals can travel in the Earth's magnetic field lines, and this makes a signal, when you convert it into sound quite like a whistle. And that means you can detect whistlers from lightning by magnetometers. And I have an early recording of, I haven't set up my audio, hang on. Oh, I'm not sure the audio share will work because I don't think I turned it on when I started sharing. I'll try this and you'll have to tell me if it's terrible. I'll just try it now. You can't hear? Not very good. Okay, maybe I'll come back to that at the end because otherwise I have to unshare and change the settings and share again. Sorry about that, I forgot that earlier. But you can hear this whistler sound.
Earth whistlers. Earth multi-hop whistlers. Earth, proton whistlers. Earth, chorus. Earth, auroral kilometric radiation.
We don't really know on Earth why you get thunderstorms at the rate we get them. We look at Saturn, they're very infrequent.
We were pretty sure that lightning exists there, but we actually couldn't see it. It's a giant planet with huge atmosphere, and there should be a lot of weather there.
We had heard the lightning on the radio instrument on Cassini, but you hear static on the radio signal, but you can't pinpoint where it's coming from. We had to use a synthetic noise because the actual noise that the radio instrument is picking up is beyond the human ear. So we picked a noise that sounded like an electrical discharge. In other words, a big spark. That's what lightning is. It's taken us a long time to see the lightning, and that's because normally the night side of Saturn is very bright because the rings are shining down all the time. The night side of Saturn is brighter than Earth under a full moon.
The strategy we chose was to look at the equinox. And the equinox is when the sun is in the ring plane, so it doesn't illuminate the rings that much. And rings become dark, and this night becomes dark.
When it finally got dark enough at night, we pointed the cameras there, and wonder of wonders, there were lightning flashes, and took a series of pictures. And in one picture there'd be no lightning flash, and the next picture there'd be a lightning flash. And at the same time, you hear the noise over the radio instrument.
And we actually saw it. I didn't believe it.
The lightning storms on Saturn are very much like lightning on Earth. You get the same strength lightning storms, or thunderstorms. They have the same strength, but they're just much less frequent. I'm enjoying the show.